Hi everyone, welcome to Module 2, Part 1, where we'll be looking at inflammation. And we'll start by looking at the physiology behind inflammation and just how this normally protective process becomes imbalanced and ultimately leads to a multitude of health problems. When we think of the typical presentation of inflammation, physical signs that come to mind are those of pain, redness, heat, swelling, and the resultant loss of function. Now, as you may know, inflammation is an essential process that provides a primary defense against harmful stimuli such as pathogens, damaged cells, or irritants. It does this by destroying, diluting, and containing both the harmful agents as well as the damaged tissue. Inflammation is a stereotyped response, and therefore it is considered a mechanism of innate or inborn immunity. This differs to adaptive or learned immunity, which is specific for each pathogen and is acquired over time. In some instances, an imbalance can develop in this immune response, and one can end up becoming sensitized to various innocuous substances, leading to an inappropriate, overactive immune response. This is the hallmark of the autoimmune reaction. So the inflammatory response plays a major role in both health protection and disease generation. Dysregulation of the immune and ultimately the inflammatory response has been linked to the rising incidence of many of the chronic diseases we are seeing more and more of today: obesity, metabolic syndrome, type 2 diabetes, cardiovascular disease, and even cancer. The term inflammaging has been coined to describe the association between aging and inflammation. Now, I'd like to differentiate between acute and chronic inflammation. Acute inflammation is the initial response of the body to harmful stimulus, and it involves the local vascular system, the immune system, and various cells within the injured tissue. It requires constant stimulation to be sustained, as inflammatory mediators have short half-lives and are quickly degraded in the tissue. So acute inflammation stops once the stimulus has been removed. The damage is neutralized and the tissue is healed. Chronic inflammation results from a failure to eliminate an acute inflammatory stimulus. It could be from an autoimmune response to a self-antigen, or may be caused by a chronic persistent irritant. It's characterized by a simultaneous inflammation and repair, and involves the activation of various immune cells such as macrophages and lymphocytes that are triggered by the action of inflammatory cytokines. So chronic dysregulated inflammation is a silent killer that underlies persistent injury and infection in both chronic diseases as well as autoimmune states. And the symptoms of chronic inflammation differ vastly to that of acute. Instead, we can see persistent aches and pains, allergies, blood pressure and blood sugar imbalances, bowel disturbances, fatigue and skin-related issues, and generally just an overall feeling of unwell. So how does one develop chronic inflammation? Well, genes can definitely make one more susceptible, but they need to be triggered by dietary or lifestyle factors, such as a poor quality diet with a high arachidonic acid intake, so lots of meats, eggs, and cheeses. And this links in with a poor body composition, which also exacerbates inflammation. Then we also have exposure to excessive levels of hormones and toxins. These can be environmental or because of a sluggish liver function or kidney function or bowel function. Then we also need to consider certain important nutrients that might not be sufficient, like a vitamin D deficiency, which can drive inflammation. But no matter the trigger, the end result is a perpetual cycle of immune activation and inflammation, leading to tissue destruction and ultimately chronic disease. These diseases can be varied and serious in nature: inflammatory bowel disease, skin conditions like psoriasis and eczema, even cancers, cardiovascular disease, neurological problems such as Alzheimer's and Parkinson's, as well as bone health problems like osteoporosis. All of these are driven by the silent killer that is chronic inflammation. Here we can see how obesity, and specifically visceral adiposity or belly fat, increases inflammation because the fat tissue secretes inflammatory cytokines. Here you can see interleukin 6 and TNF alpha, and these have a specific effect on liver function, ultimately causing the typical metabolic syndrome profile of elevated triglycerides, insulin, and glucose. And then they also increase the inflammation inside of the blood vessels, thereby contributing to the development of vascular and heart disease. As mentioned in Module 1, gastrointestinal integrity and function also play a very important role in inflammation, as a large part of our immune system is located in the lining of the gastrointestinal tract. It is referred to as the gut-associated or mucosal-associated lymphoid tissue, GALT or MALT for short. Its function is to identify potentially harmful substances or antigens and prevent them from passing through into the body. So when they identify a problem, an immune response is initiated in the gut, which can then spread through the lymph nodes to the rest of the body. A leaky gut mucosa will allow many of the antigens to pass through into the body, thereby triggering an immune response systemically. You'll recall this schematic from Module 1, depicting how gut barrier and digestive issues will allow toxins and antigens to pass through easily, activating an immune response both locally in the gut and systemically. The liver becomes stressed with the influx of toxins and is stimulated to release its own inflammatory mediators, which then contribute to inflammation throughout the body. Several studies have established the link between gut inflammation and other inflammatory conditions. So when someone presents with a condition like arthritis, you need to consider the underlying gut inflammation, which could be exacerbating the condition. So as mentioned, a very large percentage of the immune system is located in the gut. Let's have a look at some of the components. On the left, we see a healthy gut with various antibodies lining the gastrointestinal tract, Peyer's patches, which are clusters of lymph nodes, and a healthy functioning GALT, as well as lots of good bacteria, all working together to provide an effective barrier, a first line of defense against invading pathogens or allergens. However, on the right, we see a compromised gut function. And as you can see, it does not have many of these essential immune elements present. It has been damaged by a poor diet, toxins and medications, and is now overrun with opportunistic yeast and bacteria. Now let's familiarize ourselves with some of the key players in the inflammatory process. We've already mentioned the GALT or MALT, the immune tissues lining our gut. Cytokines are chemical messengers that communicate with immune cells and tell them to respond in a certain way. COX-2 enzymes are formed by cells in response to an inflammatory message or cytokine, and ultimately they lead to the production of your prostaglandins, series 2 and 3, which are molecules that affect the local immune response further and result in pain. The gastrointestinal barrier and the resident microflora communicate constantly with the immune cells located in the gut-associated lymphoid tissue. Proper dietary and probiotic signals support a healthy immune response, while poor diet, toxins, and pro-inflammatory nutrients contribute to inflammation by initiating an immune response. Let's have a closer look at how this works. When the immune cells identify an allergen, they release inflammatory cytokines, interleukin 6 and TNF alpha. These in turn recruit more immune cells, which in turn release more cytokines, and the inflammatory cycle continues. Certain immune cells create the enzyme COX-2, which then combines with arachidonic acid to create prostaglandin E2. Prostaglandin E2 is what causes pain to be signaled, and also itself initiates the recruitment of even more immune cells into the inflammatory response. Now, if you think of how inflammatory conditions are normally managed, you would think of conventional anti-inflammatory drugs, or NSAIDs as they're commonly referred to. These are routinely prescribed by doctors, and many are also readily available over the counter in pharmacies. However, this approach is not without side effects, and the FDA has now issued a health alert highlighting the dangers of acetaminophen and other NSAIDs. These side effects have been listed as gastrointestinal damage, ulcers, bleeding, renal problems, and blood disorders, as well as cardiovascular side effects. If we look at how NSAIDs work, we'll see why. Basically, their main mechanism of action is to inhibit COX activity. You may recall that COX enzymes are precursors to prostaglandin E2 production, which ultimately result in pain. Now, not all COX enzymes activity is bad, as some COX enzymes, referred to as constitutive COX enzymes, are vital for the maintenance of heart, gut, kidney, and blood vessels. It is only the inducible COX enzymes that are responsible for pain. So when NSAIDs take action, they block the inducible COX pathway as well as the constitutive COX pathway. This results in pain relief, but also negative effects on various tissues. So we saw previously how gut barrier dysfunction increases inflammation, and now we've seen that long-term anti-inflammatories or NSAID use can induce gastrointestinal damage and hyperpermeability. So using NSAIDs for pain relief can actually be perpetuating the condition it's being used to treat. The FDA's Adverse Events Reporting System keeps track of all the side effects reported for various drugs. And if we look at some of the anti-inflammatory drugs over a 3-month period, you can see that hundreds of deaths and disabilities have been attributed to commonly prescribed medications. So what other options do people with pain and inflammation have? Well, they can utilize nutrition to manage their gut issues and bring inflammation back into balance. The approach for acute inflammation could be to use proteolytic enzymes. The term proteolytic refers to the group of enzymes that break down proteins. In the body, proteolytic enzymes, including trypsin, chymotrypsin, bromelain, and pancreatin, are produced in the pancreas. Because numerous studies have revealed their wide-ranging benefits, these enzymes are available in supplemental form and can be used to manage inflammation, particularly acute injuries. Research has demonstrated the ability of these proteolytic enzymes to accelerate recovery after minor injury and reduce the pain and stiffness that often accompanies rheumatoid arthritis. Phytochemicals that demonstrate pain and inflammation-reducing properties can also be found in the herbs ginger, turmeric, cayenne, and boswellia. Human studies using these herbs have shown relief of muscle discomfort and pain, reduced morning stiffness, and reduced joint swelling, comparable to patients receiving anti-inflammatory drugs. Bioflavonoids, a broad class of phytochemicals found largely in citrus fruits, tea, and wine, are also useful at reducing inflammation. All of these compounds work primarily through inhibiting the formation of pro-inflammatory molecules. Chronic inflammation needs a somewhat more comprehensive approach, which addresses the various contributing factors to the persistent inflammation. The foundation of this nutrigenomics approach is the alteration of primary dietary signals through the exclusion of food triggers and the inclusion of anti-inflammatory foods that calm and support gut healing. The next step is to modify pain signaling by using selective kinase response modulators, or SCRMs, which work upstream of inflammatory compound production. And then the addition of key nutrients and phytochemicals, which can balance the inflammatory process, finish off this approach. Low allergy nutrients will reduce the triggering of inflammation in the gut, while specific amino acids and minerals nourish the gastrointestinal barrier. Probiotics will balance the activity of the lymphoid tissue, while antioxidants help to protect healthy cells from oxidative stress. Certain natural molecules are well known for their ability to modulate COX enzyme activity. Curcumin from turmeric, ginger, and boswellia can all modulate inflammatory mediators such as your COX and LOX enzymes, thereby reducing prostaglandin E2 production and the resultant inflammation. Rosemary and turmeric are potent antioxidants, and they also work to modulate NF-kappa B, a transcription factor that affects prostaglandin synthesis, whilst D-limonene reduces arachidonic acid release. Here you can see a list of the various natural molecules which have been graded for their relative potency in inhibiting prostaglandin E2. Some of the more potent inhibitors of inflammation are hops-derived RHEA and THEA, and you can see some of the other natural compounds that also have anti-inflammatory effects in the body. This article, published in 2005, reviews some of the research showing how hops extracts, RHEA and THEA, are able to act as potent anti-inflammatory agents through their activity as selective kinase response modulators. Kinase modulation is a major area of investment for pharmaceutical companies. If you look at this extract, they've highlighted that kinase inhibitors are relevant for their effects on acute and chronic inflammation, as they're interested in this because of their safer profile, seeing that they work upstream to bring balance, as opposed to downstream to suppress enzyme activity. Studies that have been done on RHEA and THEA have established that they have low gastrointestinal toxicity, making them a much safer alternative for dealing with pain and inflammation than conventional pain management approaches. Kinase modulators that affect PI3K activity have been identified as being key players in influencing the progression of various inflammatory conditions, such as autoimmune disorders, allergies, and atherosclerosis. Here we can see a cell with an inflammatory trigger, or a cytokine, which complexes with the receptor site. The signal is then transduced through the membrane of the cell and activates select kinase response, one of them being PI3K. These kinase responses activate NF-kappa B so it can migrate to the nucleus of the cell where DNA is stored. Specific genes are then expressed for inflammation. Phospholipase and COX-2 are induced. Phospholipase releases arachidonic acid from the cell membrane, and then the induced COX-2 turns arachidonic acid into prostaglandin E2, which is pro-inflammatory. The end result is pain. The SCRMs, RHEA, and THEA from hops are able to turn down the signaling between the specific kinases involved in inflammation, effectively reducing the production of COX enzymes and prostaglandin E2. Curcumin and ginger act by inhibiting COX activity, while omega-3 reduces the amount of arachidonic acid available to make the pro-inflammatory prostaglandin E2 by displacing it from the cell membranes. Now to consider specific key nutrients that play a role in inflammation. Here we will consider vitamin D3, omega-3, as well as specific strains of probiotics. As you know, gut-generated inflammation drives an immune response that spreads systemically and affects various organs. The active form of vitamin D3 acts as an immune system brake by inhibiting the secretion of various inflammatory cytokines in the body. Sorry about that. Let's try that again. So basically, when there's a vitamin D deficiency, it will affect the immune system's capacity to self-regulate. That is, it can mediate autoimmune conditions. And therefore, a vitamin D deficiency can lead to tissue damage through the overproduction of damaging cytokines. Okay, essential fatty acids, specifically omega-3s, play an important role as well. Research has consistently found a link between EPA, one component of omega-3, which is able to act as a competitive inhibitor of arachidonic acid conversion into inflammatory prostaglandin E2. It has been used in supplemental form to reduce the symptoms of rheumatoid arthritis, and other studies have used fish oil for the management of inflammatory bowel disease like Crohn's and ulcerative colitis to prevent clinical relapse with patients in remission. Specifically, they have used an enteric coated capsule, which has a special coating that delays gastric breakdown by up to an hour, effectively delivering the omega-3s to the site of inflammation. Here we can see how an inflammatory cytokine causes an immune cell to release COX-2, which then combines, the COX-2 combines with arachidonic acid found in the membranes of the cell to form prostaglandin E2. So basically, high levels of arachidonic acid and low levels of EPA in the body will actually perpetuate increased inflammation. There's a plethora of fish oils with varying ratios of EPA and DHA available, and they have different applications. When addressing specific ailments or conditions related to inflammation, however, the ratio of EPA to DHA becomes very important and can determine the efficacy of the therapy, as the physiological actions of EPA and DHA are quite distinct. As you can see in this summary, a high EPA ratio is beneficial for the management of pain and inflammation. Supplementing the diet with higher levels of EPA and less DHA maximizes the beneficial action of this important nutrient because it is unopposed by the competing action of DHA for binding sites and enzymes. Now, considering the link between the gut and inflammation, it makes sense that certain probiotics can be therapeutically applied to help with inflammatory conditions as well. But not all strains exhibit the same effects in the body, so one needs to be sure to use one that has been clinically researched to support anti-inflammatory effects. One such strain is the Lactobacillus plantarum 299V strain, and as you can see from this study, it was found to be useful in the management of ulcerative colitis. Furthermore, it has been shown to reduce intestinal injury and improve colonic healing in patients receiving external radiation therapy. And in this study, where they looked at serum markers of inflammation, there was a dramatic reduction in interleukin-6 and fibrinogen levels, indicating that this particular strain has the ability to reduce systemic inflammation as well. That brings me to the end of part 1 of module 2. In part 2, we will be looking at specific metagenics, products and protocols that can be used for the management of inflammation.